Alrighty. Sum of all subset exclusive OR totals. Easy. Okay. The exclusive OR total of an array is defined as the bitwise exclusive OR of all its elements. Or 0 if this array is empty. Okay. For example, the exclusive OR total of the array 2, 5, 6 is 2 exclusive OR with 5 exclusive OR 6, which is equal to 1. Given array nums, return the sum of all the exclusive OR totals for every subset of nums. Every subsets with the same elements should be counted multiple times. An array A is a subset of B if A contains. Okay, so subsets are like non-continuous portions of the array, or not necessarily contiguous portions of the array. So 1, 3, so the subsets here are 1, 3, and 1, 3. So yeah, so for the subset 1, it's exclusive OR 1 is 1, 3 is 3, 1, 3 is 1, and 3 would be 2. So 1 is 1, 3 is binary 1, 1, and then 1 exclusive OR with 3 would be 1, 0, 1 would be 1, 0, so it'd be 2. And then exclusive OR of all those 3 non-empty subsets would be, well, this would become another 2, and that would be another 2, so it'd be 0. Given array, oh, return the sum. Okay, so 1 plus 3 plus 2, so 6. Interesting, interesting. So, I think how to do this? 1 plus 3 plus 2. Okay, let's look at the second example. 5, 1, 6. So for that one, 5 is 1, 0, 1, 4, 1. 1 is obviously 0, 0, 1, and 6 is 1, 1, 0. So if you have the subset 5, it's that. Subset 5, 1 would be 1, 0, 1. Oh, sorry, 1, 0, 0. And then 5 exclusive OR 6 is 0, 1, 1. And then 5 exclusive 1 exclusive OR 6 is going to be 1, 1, 1. And if you add all those up, you get 5 plus 1 plus 6 plus 4 plus 3 plus 7. So it'd be 10, 20, 26. 26. Oh, so I forgot the 5 exclusive OR with 1 exclusive OR with 6. In which case, the 1s would cancel, those 1s would cancel, and you left with 0, 1, 0. So it'd be 2. Okay. Okay. So what I think the pattern might be is how many times does 5 appear? Does that matter how many times 5 appears? Alright, so how big are these things? There should be 20 in the 20 elements in the array at most. And no, sorry, 12 elements in the array, and at most the values are between 1 and 20. So pretty small values, to be honest. Is this one where I feel like there must be some sort of simplification of the calculation. like if you do an exclusive OR of an element and itself, it becomes 0. But I guess you're not doing exclusive OR of the values within the subarrays, subsets. So it's not really canceling, like this 5 doesn't really cancel with this 5, I don't think. So there's the brute force way, which is actually calculating every subarray and every exclusive OR. I guess I can start with the brute. No, the brute force ways would be like, that'd be a lot. If you did, it would be a lot. Well, okay, so if you think about, there's going to be at least, the sum will at least include the sum of all the elements in the array, because all the elements in the array could be its own subset. Could be a set within this. Yeah, it could be its own subset. So that's at least one. And then what? And then you do the exclusive OR of the first element with everything after it. But then you also need to do the exclusive OR of the second element with everything after that. I wonder if that would work. Exclusive OR of 5, everything after that. For each element, do the exclusive OR of that element and everything after it. And then you have to do the, I wonder if this is a backtracking one. So you currently have the values within the set, and for each later one, yeah, this seems like maybe a backtracking one. There's only 12 elements. So if you did backtracking, where you call on the next iteration, the 12 would be 12 stacks on the call stack to do backtracking. Yeah, okay, I think this might be backtrack. And so when you do the backtrack, I think you want to have the index that you're dealing with and the current value. So let's say the answer is originally 0, and you want to call backtrack index 0, current value 0. I guess current value. Yeah, actually, current value is actually the return. So I think you also need like the set of values that are currently in the. So you have a set, I want to say. Let's do it like this. You have an index, have the values that you currently have in your set, and the values themselves are they passed in, or do you just keep track of it outside? I think we can keep track of it outside. Values is equal to a set of numbers. Is it going to be a set, or is it going to be an array? issue with sets is you need to actually have, I guess if you have the same value multiple times in the set, then you can just remove it from the set. So I don't think we need to worry about how many times something occurs within the set. Okay, so the values, this is a set, and I guess I don't need to pass it. So what can I do here? If the index is 0, then the value is going to be the nums at this index. Actually, let's say n is equal to the length of the numbers. And if the current index is n, then you have to finish it. If index equals to n, but with current value, okay. Yeah, you need to actually increment answer. Answer plus equals the current value in this set. Okay. And the values is equal to nums at this index. And there's going to be two subsets that are identified. One including the value, include value within later subsets. And then, actually, let's do it reverse. Not include value, skip value. And so if we skip the value, then we just say backtrack index plus 1, current value still whatever the current value is. And then I guess this doesn't return a value. Okay. And otherwise backtrack index plus 1, current value exclusive OR. Actually, maybe this should be called current total. Less confusing with current value and value. I don't know if this answers can be, yeah, it should be fine. I think that's it actually. And I guess if you call backtrack, it doesn't return anything. Backtrack 0, 0, and just return answer. Oh, whoops, you need to include the value in the later subset. So value dot so this isn't quite right. So I need to add it to the subset and then I need to remove it from the subset. I need to add it to the current subset. So by adding it to the current subset, is it just not? So add it to the current subset. And then remove it from the current subset. Maybe I don't need to worry about that because total's keeping track of everything. So what's going to happen? It's going to call 0, 0, and then it calls 1, and then 2, and the total doesn't change. And then at the very last one, it's going to call 0, total is going to be 0, exclusive of value. And that's going to increase the answer. And then it's going to go back. I'm going to try it and see if this works. Answer is not associated. Yeah. think maybe I can just make this self and say this is self.answer. Missing operation. Oh yeah, so now I made self. I think this should be self.answer by the way. Index out of range. Oh, when it reaches the end, it needs to return immediately. Okay. Alright, alright. Guess there was a faster way of doing this. This is like a 1 millisecond way, 0 milliseconds way. This generally, I mean, backtracking generally isn't the easiest thing to do. I wonder if there was a better way of doing this. So, have some set of values. You have some set of values. The values themselves are fairly small, up to 12 values. So for each, okay. Generally, when you have backtracking, there's a recursive function way of doing it, and there's a for loop way of doing it. Let's see if I can do the for loop way of doing this. Recursive method to backtracking. So how do you do the for loop way? It's going to be, you have a stack, and then you have elements in the stack that are your sets. So for every, I think it's while true. How would you do this? You have a for loop that goes through every. No, you have a stack. It has to be a while for loop for doing this. So you have an empty array, and then you have a certain index. For loop backtrack implementation. So if not visited, if not visited I is true. No, this is the way. So you have a set of things that you've visited. So for each element in your array, so I in range of num, so index, if you haven't visited the index, you're still calling backtrack. Say num's visit true while picking num's I, before the answer path. So for each, you can say n equals, you definitely need to know the length of the nums in this case, for index in range n. You either I feel like it has to be a stack. You either pop it onto the stack and then move forward, or you don't pop it on a stack and move forward. So is there, you can't do a bunch of inner for loops, there's no way. So I guess you could do something where you have a while loop and you're doing a count of the number of times you've done this. While count is less than the maximum number of things that you want to do. Gosh. What was the way of implementing stats with recursion backtracking? Take two, you have an empty array, put 2 on it, put 5 on it, put 6 on it, and calculate, pop 6 off it. So for each index, if you've seen this index, if you haven't seen this index, then move forward. If you have seen this index, then I think, is it while true? If you have seen this index, so if you haven't seen this index, move forward. If you haven't seen this index, then put this value in put this value in the array, put this value in the set. So you have maybe you have a stack. If you have Let's say you have values. So this stack is your values. So maybe this should be while true. And let's say we have an index. And we have a scene, which is originally a set of false for every index in nums. If you haven't seen this thing, then that's fine. So if the index is equal to n, then the answer plus equals the current total if, and then you backtrack. And you say n minus equals 1 and continue. So if it hasn't been seen, then let's say seen at this index is not true. Seen at this index is not true. Index plus equals 1. Else else what do you do here? If you have seen it, then this is the second time and you need to add your element to the values. So total should equal total exclusive OR with the current value, and seen this index should be true. Well, I guess it doesn't matter at that point, because you already have it be true here. Oof. Man, I'm screwing something up pretty badly. We have an exclusive OR stack. So for each index, you add the value to the total. No, you first, I think it's easier to just skip the value at that index. So you skip all the values, and then you're back to, and then you hit the last index, which is index n, and then you backtrack to index n minus 1, and then you add that value to your total. Add that value to your total, go up to n minus, go up to n. Add that value to your total, go up to n, and then what? And you set scene. Go up to n minus 1, you go up, you add the 6. Alright, let's think about this. So we have empty array. So you skip the 2, you skip the 5, you keep the 6. And then your first total is going to be total plus equals 0. And then you backtrack to the 6th spot and you add the 6. And then you do total plus equals 6. At that point you've seen the index. So if you've seen that index, so when you backtrack it, if you've seen the index, then you need to set scene to false. If I go into a loop, maybe it shouldn't be just while. Maybe it should just be using the values more effectively, using a stack more effectively. So add to dang it. Maybe this has to be a stack way of doing this. It has to be a for loop way of doing this, or a while loop. So let's say you actually add 2, 5, 6 as your starting point. You hit index equals n, you add up the total, and then you pop off stack 6, and you recompute the total, and then you pop off the stack 5. Doesn't quite work. Right, what was the other way of doing backtrack? Bracket. Let's say this one. Did I not make a solution here? I'm gonna solve this stuff. I'm gonna solve this thing. Okay. Solve it using recursive functions. But still using for loops. But it's using for loop with a recursive call. I guess it was just based on the fact that that you could have multiple things as possibilities at each index, but it's still backtracking. Yeah. I guess still. I thought in general there's every time you do a recursion, you can do a for loop. All right. Maybe that's what. All right. Let's see what actual is the actual super fast way. I and nums. Answer. This is or the answer with the current value in nums. And then answer is the bitwise shift. What the hell is going on? Answer is the length of nums, the number of elements, minus 1 shifted. All right, this is definitely beyond my general understanding or want of understanding. Okay, cool beans. Oh, I should probably do one last thing, which is this is still the person pointed to backtracking. All right. Well, that was chase. So summary of solution. This is use recursive function to iterate over indices of nums array for each index include the value in total and call on next recursion and make next recursive call updating index and total. And also make recursive call that value. Base case, the non-recursive case of call is when index is n, at which point then just add total to answer. So this is the base case right here. This is the non-base case. These are recursive cases. And this is misspelling within. Recursive number 1, and this is recursive number 2. Alright, and then each time you hit the n case, which is the indexes equal to n, you add it to the answer. Here I used, because I didn't want, I could have used answer as a parameter, but I kept it as a kind of a, I consider this a field of the method, instance variable method, so I just made it self referential. So I just made it refer to the self answer and then pass the self as a way to access that. Alright, and I think that still all works.